Hi there everyone, this is Jeff Sharman speaking and I shall be your instructor on this training. I have many years experience in control systems, instrumentation and PLCs. Now this short extract from one of my lessons is an introduction to PLC ladder logic programming. So please sit back and enjoy. Thank you. Hi there. I'd just like to show you something about ladder logic programming. Now, ladder logic is a very popular programming language in PLCs and in automatic control. It is used universally. Now, what I'm going to show you here is a ladder diagram, what everything means within that diagram, and how it actually works. In the old days, you used to wire things together using wires and components. Like here we have two contacts and a coil. In hard wiring you would have two switches and a wired coil, and the rungs would be wires connecting them together. Nowadays it's all done like this in software. What does it consist of? You have rungs, you have instructions, and these are input instructions, and you have output instructions. In addition to that, you have branches where you can divert the flow of power to the output. Then we get the program flow. Here we have rungs. How does the program flow operate? Always it operates left to right, top to bottom, no exception. That's the way it goes. Here we have a rung and a branch, and the program flow is identical. Left to right, top to bottom. It will go through the rung first, and if it isn't energized, it will then go through the branch. And you will notice on the rung we have two outputs in series. This isn't normal in a conventional PLC, but it is fine in Logix 5000. It works beautifully. If we have a look at some ladder where we are online to a controller and the controller is running, you will see the power rails on the left and right hand side are green, which tells you there is power. You have input instructions, you have an output instruction. If the input instructions are closed, you will see the green. This will then bring on the output. If one of the input instructions is off, with an AND gate, the output will stay off. The instructions commonly used in ladder, you have a bit instruction called XIC, examine if closed, which is an open contact, XIO, examine if open, which is a closed contact, and an OTE, output energized, which is an output coil. Now, examine if closed, when it is true, it will allow current flow. Examine if open, when it is false, it will allow current flow. And the OTE, when it is energized, it will show current flow. You have a one-shot instruction also, where if the switch in front of it goes from false to true, the one shot will execute for one scan only, and it will execute the add instruction. It won't execute again until the rung goes again from false to true. Here we have some latch instructions. Output latch, whereby if the input goes true, the output will come on. If the input goes false, it will stay on. Then there's the output unlatch, and this is used in conjunction with the latch instruction. They're used together. The only way you will unlatch that latch instruction is to use the unlatch with another condition in front of it. You have to be careful how you use these. Here we have a timer demonstrating what is called seal-in logic. In other words, you've got logic with a holding contact on a branch. So you press the push button, the timer will start. When it starts, the timer timing bit will come on and give you continuity to keep the timer running until the preset value is reached. When the preset value is reached, the timer timing bit will de-energize and the timer will be ready to time again. The done bit will also come on. So I hope that's given you some idea what ladder logic is all about. It is used extensively. It's probably one of the most popular programming languages that is in industry. So I would advise you to take the rest of the course because it gets quite interesting. Bye.